that. Good morning, or really whenever you're watching this. Right now it's 7:41 in the morning where I am. And I had this idea last night to look at LeetCode and implement as the top lists in Rust. And I thought, well, okay, this will be both just a fun thing to do as well as a sort of perhaps an interesting thing to do in Rust. And, oh no, did we lose our stream? Okay, maybe we're okay. Okay, haven't really done this before, but here's what I'm looking at. If you go to LeetCode, they have like the top 75 and the top 50 questions, which are interesting because if you look at both of them, the top 75, you have, let me see if I can put these side by side. You have your top 150 and your top 75 here. And they're different. They're notably different. And you would think that if they were actually the top 50 and the top 75, they would overlap by half. But they don't overlap, at least in these first couple with the arrays and the strings. There aren't duplicates. So anyway, kind of brings to question how curated these lists are, but we're going to do this anyway. We're going to grab the first 75 here, and we're going to implement them. And we're going to do it in Rust, and I don't have anything prepared yet. We're going to do everything from scratch. So I'm going to see if there's anything I need to do. I'm sure there will be some things I need to do off screen. So let's do this. Let's bring in, here we go. So I'm going to go to GitHub, and I'm going to create a new project, and we're going to call this LeetCode Rust. We're going to leave it public. Let's add a README file. I believe now they have a git ignore for Rust, and we'll make the license be Apache. That's fine. Just for fun, I want to see if I'm streaming here. Nope, that's not what I want to say. This first part's going to be really awesome to look at. Okay, it does look like I am live. So we've created, or I have created, I use the word we all the time. I've created a template here. So let's come in here to, I need to start up need to update my Stream Deck here. So I have two different scenes here. Give me a second here. Full screen 2. Let's see what our two scenes are. There's our full screen, and then there's our video. Good. That should be good. Okay, so hopefully I don't expose too much. So I want to clone repository and container volume. I'm going to grab it from GitHub, and we're going to grab LeetCode Rust. And we're going to grab the main branch. So I do 95% of my work in development containers. Let's do this again. Sorry. Clone repository and container volume. I'm going to clone this from Git repository. I'm going to grab my LeetCode Rust, the main branch. It's going to ask me to add dev container files. I want Rust. And I want this is the Debian OS version. I'm going to get that. That's fine. We'll just take all the defaults. This should start up pretty quickly because I use this container all the time. Okay, so here's my dev container. I want to change this to use latest. There we go. And we're going to rebuild it. Good to go. It's actually really interesting to watch this pull in the containers. This effectively gives me a sort of a virtual build environment, or it's almost like a whole virtual machine where we're running this just inside of a container. And I get it; it's not a full virtual machine. I understand what the difference is between a container and something running inside of a hypervisor. But here, let's go. Let's just start. Actually, in another window, I'm going to go cargo install, cargo watch, and cargo next test. Just going to let that cook while we get our other systems ready. Cargo new LeetCode _rust. And I'm going to move that in /star into here and remove LeetCode rust. Cargo build. Nice. Cargo test. Look at that. We're already passing all of our tests. Let's check this in. Initial check-in. And we're ready to go. Once this install finishes, we're going to run a little CI to keep that cooking. Otherwise, let's go into Zen mode and open up that. Let's let that watch, and we actually have a main. So we're going to do a new file, and let's make this a lib.rs. And let's bring in our first victim here. So our first problem, whoops, that's not what I want. Am I still streaming? Good. First problem is going to be this. So we're just going to pull off of LeetCode 75. I started to look at 150, but we're going to look at 75. If I'm get going, it'd be nice to be able to finish all of these in about an 8-hour period. That gives me about 10 an hour, which might be aggressive depending on how much we're talking here. Oh, look at this. We don't have rest here. Oh, we do. Impulse solution. Merge alternately. What solution? Okay. I don't know if I'm going to be using this. Let me go ahead and sign in. Let me sign in sort of off screen here just in case it exposes anything I don't want you to see. Okay, I think we are ready here. Let's just see here. Okay, we have finished this. I'm going to run cargo watch -x. Oops, here we go. Next test. I'm actually curious over here. I want to be able to see my stream. Just wonder if anybody's watching. That would be interesting if people are actually watching. No views. we're going to stop this. Okay, I don't know if this is going to skip the first section or not, so I'm going to do a quick reintroduction of this. Wow, my hair looks really nice in the morning, doesn't it? We're flipping our microphone here. Let's bring this down just a bit. Okay. So what we're doing is I'm running LeetCode, and we have LeetCode window here. Good. So we're doing all of the LeetCode 75 or 100 in Rust. So give me a second here just to order these a little bit. And okay, let's go. Merge strings alternately. Like I said before, really what I think I would want you to get out of this is not here's how to do all of the code examples, but really like, this is this might be good ways to set up a Rust development, or here's how I think, what's going on. So let's just get into this. I'm probably going to do this. Let's do a config test mod tests, and I'm going to pull in. I am using GitHub or Copilot right now, GitHub Copilot, but I don't want to do this in the actual version of this. Hello world to string as stir. Good. Okay, so I'm running my CI down below, and up above we're going to do our implementation. So let's go here and pull in some of our here we go. Let's bring in the tests here. So we have some examples here. Let's just talk through the code here, or the question. Merge strings alternately. Given two strings, word 1 and 2, merge the strings by adding the letters in alternating order, starting from word 1. If one's longer than the other, append the rest. Return the merged string. Okay. So we have, here's two inputs. So test merge strings 1768, and let me turn off Copilot at this point. No actions are available. Can we disable you? Okay, let's go into our extensions. And I'm going to disable, reload to disable. Sorry, I don't know when I'm showing you what screen. I apologize for that, because this is going to be obnoxious for you if you don't see my screen all the time. So now I have Copilot disabled. I still have Rust Analyzer enabled, but let's do our work based off of this. So let's go back into Zen mode, and let me pull in our examples here. Let's do this. And this will go faster as we get good at this and start having some commonality between that. So we're going to let word 1 equal ABC, let word 2 equal PQR, let expected equal APBQCR, and assert equal, this is returning a new string, I believe. So in this case, we are going to assert that AP expected is going to equal solve merge strings 1768 with word 1 and word 2. Okay, so this won't run, but we'll get there. Good, that still works. Okay, so now let's solve this. Fn solve these. Word 1 is going to be a string reference. Word 2 is going to be a string reference, and we're going to return a new string. Okay, so we just need to interleave the two. Here's our work. Return the merge string. These shouldn't take full strings. They should take string references, but we'll let that go. What new? We're gonna do this, or I'm gonna do this in a good way, and maybe we'll go back and do it better. There's sort of a difference between let's solve this and let's make this be the absolute most efficient way that we can do it. And we really have to balance those two as we do this work. Okay. Let mute output equal vec new. And for let word 1 equal word 1 cares. Let word 2 equal word 2 dot cares. So now we have two iterators that point to, or that are the characters in these words, and we need to bounce back and forth between the two. Since this is the first one, I'm going to play around with this a little bit. Interleaved equal from fun, and we're going to move. These are going to be mutable here as well. So let's do this. Word 1, word 2. And just curious how we, yeah. Words equal words into iter cycle. Words dot next. value equal words.next if okay, or no, it's we'll just do it the standard way. If value is if, oh shoot, I don't know. Let's just do it straight with this value dot and then or else. I don't want to have to move this in. Let's just do that this way. If let sum value equal value, then we return some value. Otherwise, we return words.next. I think that is our interleaved version of this. So I believe now we can return interleave.collect. Can we collect straight into a string? I don't know that we can. Type of string cannot be. This is where I really appreciate Copilot, because using Copilot is going to be able to tell me what it is that I do to convert iterators into strings. But let's collect this into a vec of chars. So now that's a vec of chars. Oh, I think I can do string. Oh, output into. I should really know what this is. I don't. Hold on. Supposed to do it. Oh, words.next, unwrap.next. There. Now it's a vec of chars. So we can just interleave that and collect it straight into our string. Now let's see. Oh, we don't have this mutable. And yeah, we don't need these to be mutable. Good. So this is running forever because our next here, this really needs to be iter, I believe. Cannot borrow at as mutable. Next clone. Because we need that to be a real char. Cannot borrow that as mutable because This is really like going completely ridiculous in the implementation of this. I'm hoping that once we get going on this, this will smooth out and will be useful for this. So they're right that that needs to be, I believe I have to put this into a ref cell. Import unwrap borrow mute next. Ooh, this worked. Okay, so actually I want to change this. Let words equal move bang words.next.unwrap borrow mute. Good. Words. Boom. This has got to be mutable. This doesn't. Cannot borrow. This is mutable. Okay. Good. Okay, we're still working. So this is so not how you would implement this in any like actual LeetCode sort of thing. Like from an array point of view. Like if you were thinking about this from, okay, I'm going to have 2 pointers and I'm going to iterate through these and create my create the result type. This is doing it entirely with iterators and is a little bit unorthodox. But I would actually sort of challenge what the efficiency or the effectiveness is of this. So what we're doing here is we're saying, okay, let's get, we turn our word 1 and word 2 into character iterators. The 2 words we're going to be cycling between are words here. So we create an array, 2-dimensional array of that. And we have to put this into ref cells because we need to get at the inner type mutably. And we don't want to use unsafe. Words here now is we're cycling. So every time we get the next word, we are going to get one or the other of these, and we're using iters so that we're not we're getting at the reference of what's in there, of what's in the array. And then I actually turn this into a function because this unwrap, probably want to do this safety, not hash, unwrap will always succeed, if I can spell, because of the cycle. So getting the next word that we're going to be using, we unwrap it here. And anytime I want to do this sort of, if I ever want to use unwrap, you're supposed to put a comment saying why this unwrap is safe. And I always want to put that as close to the sort of the evidence is that this is going to be Okay, so here we just have to look at the previous line to know that cycle is there. So if we were to ever to like change this to find where this unwrap is actually valid is easy to find. And then we're calling borrow mute because we're getting a reference to the ref cell, and we want to borrow it because we need to modify that word because we're consuming the iterators that are inside of here. Whew, there's a lot going on here. The interleaved gives us another iterator that is going to call this function or this closure every time we're getting it. So we get the next value of that iterator. Of our words, and if we're doing left or right, and one of those may be not valid, and if so, we're going to pull from the other one. Otherwise, we're going to return it. And this is really just guarding against the case where value is empty. Where value is empty, where we've consumed one side. So I don't think we actually have tests for consuming one side or the other. So let's go ahead and add those here. So assert EQ. What's our other one here? AB. Oh, sorry. We're going to have it be APB. I just need some more real estate here. APB QRS. Solve, and we're going to give it AB and PQRS. And that should pass as well. And we're going to do one more. ABCD. Nope. APBQCD. And we're giving it ABCD and PQ. Good. So this is solving it without any of the solving it using purely with iterators. And let's go ahead and go back over to the window. Oh no. I did all that work without you seeing it. I'm sorry. Here's what it looks like. Man, go back, dub it over, and gosh, that was a really good one. Let me just walk through that. This first one's taking, gosh, almost an hour to do. So we get iterator versions or character iterator versions of the words. So word 1 and word 2 are now an iterator of all the characters. We put those into a two-dimensional array, wrapping them in ref cells because we need to be able to modify the internal. And just because of rest borrowing rules, this is what we have to do. We cycle words, so this is going to bounce back and forth between word 1 and word 2 every time. I wrap words into a function because I'm going to be using unwrap, and I want to have this be close as we can. So this is just going to get us the next character from the words. And so our actual interleaved iterator now says, okay, let's get the let's put a comment here. Get the next character from the next word. Yeah, that is what it says. If there isn't something in that character, a character from that word, get the next character from the other word. The only thing that's like in this case, when we're draining the other word, it's going to be bouncing back to the old one, seeing that that fails and goes back. You could optimize that if you really wanted to, but to turn that into a state machine in here is just not helpful at all. So anyway, let's copy this in here, and let me see if we can paste this into our solution. And how do we run this? Run. Oh, we need to bring in ref cell. Run. Good. So this worked. Can we format to use autocomplete? No, we can't. Okay, let's just submit this. Good. What does this mean? Beats 100% of the others. I find that wow, they have 108 test cases. That's nice. Interesting about the memory. I mean, we're at 2.2, 2.3. I don't know. Curious here. Just because I haven't seen this code. Well, that's I'm guessing that that's a weird time complexity. Let's analyze the memory spaces and okay, whatever. Let's go on to the next. How do I go on to the next code? Next question. Good. Greatest common divisor of strings. Man, we're only doing like one an hour, but that was a good one. I like this just from a like let's just from the point of view of this. I can't imagine that there's other people that implemented this way. Well, I can, but they're not likely to do this. Greatest common divisor for two strings S and T. There we go. Say we we say T divides S. If and only if S equals a bunch of T's, T is concatenated with itself one or more times. What the hell? Given two strings, string 1 and 2, return the largest string X that divides both stir1 and stir2. So let's see this again. S and T, we say T divides S if and only if S equals T concatenated more times. Divides both stir1 and stir2. Okay. Let's write a test here. Test. They call it GCD. GCD strings. What number are we at? 1071. Okay, assert equal ABC is going to be solve GCD strings 1071 of ABC, ABC, and ABC. Good. So let's go ahead and implement this pub fn solve strings, solve GCD. What do we call this? Stir1 and stir2. Stir2 is at stir2. And I guess we have to return a string, right? They use strings for everything. The inputs for these really need to be string references. That's not right at all. I mean, it is right, it'll be fine, but you shouldn't be passing in strings as arguments almost ever. There's almost never a reason to do that. Unless maybe you have like a mutable string, but even then, like you're really doing an output type. So, okay, so I believe we're really looking for we need to generate substrings and do a test between each two to see if it does. So we just need a test here. String divides stir. Let's see. We call this T and S. T. So we have one string here, and S is another stir. And we're going to return true or false. So how do we test this? If S is T concatenated with itself one or more times. Probably exactly, I would say. We can do this again with iterators. We're going to have that be chars and let T is T chars. So we want to, well, we're going to do a normal loop for C in T, because T is what we're testing. No, for C and S. Let next T equal T dot next. We need to know if we're at the beginning. Well, we will need to know that. So that's going to be an optional. We actually have a version here, so T, if T is empty, return true. We don't actually, that's not in the spec, I'm guessing, but let's just do that. So T is always going to have something in there. So if let sum next T equal next. There's an else sort of thing. What's the code here? If next T if let sum next t equal next t next t, else we need to t equals t cares t dot next dot unwrap. T always has cares. This is safe. There. So that is our next. I don't like this. This might be there might be a better way to do this, but let's get this implemented first, and then we'll see where we go. If c does not equal next t, then it's not return false. Okay, when we do drop into here, we want to make sure that the that t is empty. So we just return t.next is none. I think that should do it. Oh, this is just our test. So I actually want to let's run to do on this. There we go. Down here. I want to test my what's it called? Stir divides. So in this case, stir divides. So t is what we're testing, right? Yeah, t is going to be concatenated. So this is where ABC is going to divide ABC and ABC. Good. If there's an extra character, this should not. I'm just going to force it to fail. Good. If there's an extra character in here, that does not. Good. So I think our divides function is correct. If not a little bit ugly, but not really. I mean, because we're always using iterators here. I guess the things that we could do here. Let's say let t in equals. It's got to be repeatable. Move t dot in t in cares. Yeah. So we're just turn t in into an fn to get the next cycle of character. That's sort of it. So now we just need to call this as a function. Apparently, oh yeah, we don't need this to be mutable. Good. It's a little bit better. This always then will, like this is just how we get characters from this. S.cares Good. Okay, I like this. So now to solve this, we just need to walk through either one. I think either one can be walked through. So let's undo our assert here on our solved. And let's actually put in all of our, well, let's just do one for now. So we just have to build out our strings. And like I said, I think we can use either one, but we might have to use the shorter of them. But I'm not sure if that's true. No, we can just use either one. So let's just use stir1. Let's call ranges. Is going to be from 1 to stir1.length. Like these are all of the ranges of strings. So like if this were, well, so like if, let me just do this. If stir1, say that stir1 equals A, B, C, D, E, F. Ranges will return 0, 1, 2, 3, 4, 5. How many are there? 7, 6. It only goes to 6 though, right? So I need to check to see if, actually, let's do it this way. This is actually kind of interesting. Grow string stir. Let's just call this S. We're going to return an iterator, an impl of an iterator, where item equals string. So what I want this to do is s.len, and I'm probably going to do from function move. So s next. And let's do this. Let ranges equal ranges.map max, and we're going to return from 0 to max. And I might be off by 1 here, but I'm gonna work that out in our tests. I don't need from fun. So ranges map R, and we're going to do, let's just do, we're going to run filter map because s.get R. You could do this, but it returns an option stir. Oh, yeah, because we don't need that. Good. I like that a lot. Because assert grow string ABCD. Let's collect that. Let's do our bang here. So this is going to return A, AB, ABC, ABCD. Good. So we're missing that last one. And I thought we were going to, because we need to just have this go all the way to the end here. Dot, dot, slash, equal, dot. Good grief. There we go. So, grows returns permutations of S, where S goes from length 1 to length s dot len. So, like example, s equals ABCD, returns A, AB, ABC, ABCD. Yeah. So here we don't need all this stuff. We can just do possible is going to be grow string, and we can just grow stir1. And I'm going to say this is an optional string. We can actually, we don't need to return a full string because we have the substring in ours. We do need to have some lifetimes. It's really just going to be that one. So we're going to grow the string. Those are all the possible. And the biggest is we don't have anything yet. While stir divides, so the one we're testing is so we're going to test our next possible. That's got to be mute. That's why it's complaining. This is going to have to be mute as well. There's probably a way to wrap this in all of them. Yeah, but let's not deal with that yet. So if what else break, we're going to return the biggest. So in this case, both of them have to be dividing. Stir divides. The test is this, and stir1. And stir divides. Good. So, biggest equal test. some test. There we go. Stir2 is never used. There we go. So I'd like there not to be the loops in the tests. And I'm sure we can do this, but this is pretty clear. So let's go ahead and put in that. Cannot compare. Oh, because what do they want the false condition? Yeah, they want the false condition to be an empty string. Don't do that. Just don't. Okay. So here, ABC, ABC. Oh, good. Let's debug. I'm curious to see. So we're going to go in here and our possible loop. So what is test? Test right now is I don't know how to read that. Well, oh, so there we go. Now we can read it. So it's an A. So it says that, let's go back and reset this. Let's run it again. Go in here. Let's see. It's not empty. We're getting our characters. We already know that this does this divide. Oh, we actually just need, the largest string such that it divides both. So we're gonna hit ones at the beginning that do not. So this actually will perhaps take some of this out. If we were to grown, good. We're not going to break here though. That'll probably be passing. Good. So, and I wonder if you can just go, if you could go backward. You could go backward in that you're testing the largest and then finding the smallest. Let me actually see here. Let's put in our other test just to make sure. So here, our test here, this should return AB. Oh my goodness, you've been looking at the wrong code here. Okay. Man, I need to get better at that. You'll see it in a bit. So here's our first string. Here's our second string. And we have another one, LeetCode returns. It should really return none. There we go. So like this is working, but let's go backward. Really need like a grow string reverse. ABC, AB, A. So I think We can go from S, 1 to this. I think that'll just work. Yeah, let's just check. Grow string reverse, A, B, C, D, A, B, C, A, B, A. Nice. Okay, so now we have the ability to grow it in reverse. This is just going to be now the first one of it. So let's copy this. And let's just call this reverse. So we actually, it's going to be the shortest one. Shortest is going to be if stir1.len is less than stir2.len stir1. Otherwise, stir2, we're going to take all the possible from the shortest and we're going to reverse that. We don't need to keep track. If there is something down here, we're going to return none. If it does divide them both, we return sum of test. I think this will do it. We do have to fix our lifetimes because it could be either one. This is like that classic version of why you need to do lifetimes. But let's see now if this passes for all the reverse ones as well. There we go. So I'm sure that this is going to be like the fastest that we can do. But let's paste this in here. So here's the version that is reversed. I'm going to shrink this so I get more space. And we also need to have our test here. And unfortunately, this is returning a full string, so return test dot toString. God, that's ugly. Like you absolutely should not do this. Return to string. Cannot find function grow string reverse. Yes, because we did not include that. Grow string reverse. There we go. Run. Oh, good, because you're not looking at this either. Good grief. Expected stir found a full string. Right, because they used the wrong version of it. Run. There needs to be like music. String divides. Because stir one. Borrow a moved value. I didn't do that over here, did I? No. Okay. Good. So that works. And I think this is going to be as fast as we can get it. So let's go ahead and submit this. I do wish this had a code formatter. Beats 13%. Three milliseconds. 80.07 uses 0. Okay. I wonder what the range is on this. Okay, let's move on. Kids with the greatest number of candies. Let's remember to switch over. First, 2. Where are we at with time? We're going slow. Okay, let's see this. Kids with the greatest number of candies. There are n kids with candies. You're given an integer array candies where candy sub I represents the number of candies the ith kid has, and an integer extra candies denoting the number of extra candies that you have. Return a Boolean array result of length n where result is true after giving the ith kid all the extra candies. They will have the greatest number of candies, false otherwise. Okay. 1431. Kids candies. 1431. Keep bang. So this is a vec of bools. This should not. This should be a slice of I32s, but I really want to fix that. But we'll go on with this. Good. So this is our return. Vec bang of that. And solve kids candies 1431, where we're passing in that and 3. Okay. Fn solve kids candies, and candies is a reference to an I32 array or slice. Extra candies is an I32. Why an I32? Should not be an I32. At best, that should be a U32. Just going to do it. We're going to return a vec of bools. There. So this should compile but fail. Good. Okay. Let's see here. So we need... They will have the greatest number of candies among all the kids, false otherwise. Wow. Okay. Well, let's here. Let previous greatest is going to be candies, iter, max. All right. It's an option because candies may be empty. That's fine. I think this will still work. Yeah, we can keep that a reference for now. We do copied. Yeah. Okay. Because I it's fine. Whatever. Unwrap where. The reasons why I want to do it this way. The rest of it's going to be able to return an empty vec. So this is just giving me a full U32 on the stack that I can compare against. It'll be easier to compare against that than dereferencing something through an option every single time. We're going for speed here. So now we just need to return candies.map C iter map C. This is going to collect. So here C is a U32. We're just going to return C plus extra candies is greater than or equal to previous greatest. If it will be, oh. But you have to know how many they had before. Is that going to change anything? I think I can, among all the kids. So it is just an if. Every single one is not dependent on the previous one. So that is right, I think. Gotta make this pub so that it doesn't compile out. Good. So that this is right. So this one, this is going to return this guy. Yep. And our last one here. Extra's 10. And we are returning this. Good. Okay. Since I didn't play nicely with the other one, this is an easy one. But let's do this. Candies iter map. That should work. Good. Let's submit that. And we do pass. Beats 100% of all of them. That's weird. How many are in here? How many people submitted? Do I know how many people submitted? Okay. Next. Can place flowers. Okay. Again, I think I screwed up my window. I need to fix that. It's just my own thing. You have a long flower bed in which some plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Okay. Giving an integer array flower bed containing ones and zeros, where ones means empty. Why do they not mean true? Or why are these not bools? 0 is empty, 1 is not empty. And an integer n return true if n new flowers could be planted in the flower bed without violating the adjacent no flower rule. Okay. What's the no flower rule? Flowers cannot be planted in adjacent plots. What does this mean? So here in N1, that just means that you could put flowers there. Okay. Okay, let's go do this. Here's our code. Let's go do a test. Test, what are we calling this? Can place flowers. What's the number? 605. Assert EQ that true. Solve can place flower. In 10001, where n is 1, and false, where n is 2. Okay. Pub fn solve can place flowers. Flower bed is a reference to I32. Okay, I'm going to actually fix this. N is an I. It's got to be a U32. And bool. So I think we're just going to like walk down and try each one. Like, you know, can we put it, drop down the number of flowers and but impl trait flower. So I'm going to do a thing with traits here. Bool occupied self. Oh, do we want an index? Yeah, we do want an index. It's going to be a use size, and that's going to return bool. Yeah. So we're going to impl flower bed for an array of I32s. Fn occupied, good. Self sub, I always want this, index. Unwrap or actually we're going to unwrap or let's just do 0, it doesn't matter, equals 1. I think. Oh, this is going to give us a an optional of a reference. So this is like how we implement flower bed for that. So this is going to be a slice of, actually this is going to be an impl of flower bed. It could be a reference to an impl of flower bed. To do, bang. Okay. Flower bed is not implemented for integer. I'm going to mute myself for a minute here. So I'm actually going to change this. Trait is going to be flower bed space. This is going to return occupied for just self. Flower bed space. Occupied for self. Impl this where impl flower space for I32. Oh, we just do this. So this then is an impl of an iterator. Well, it should be from it or into iterator, where item equals an equals an impl of flower bed space. Did we do it right? There we go. This is like almost overkill. Occupies never used. To solve, so we're going to pass in that. Okay, I'm only muting because my wife's walking around. I think now I can just take that off. Yeah. We need to know for every space that is not occupied, can we plant a flower in there? Okay, I'm going to change this a little bit. This is going to be a reference to something that implements flower bed space. Okay. So I want to test.
Oh, it's so nice putting on chilled shoes.
Okay, just want to talk through this. I was going to say that cases are not matched. This needs to be. I'm saying, okay, can we plant in a space? And I want to give this a space here. So what this really is, given we're really looking at a slice of 3 here, and we want all 3 of them to be false. That means that we can plant in this space. So this one, middle one is space. So we're looking at these 3, and they all need to be sum of false, sum of false, sum of false, true, otherwise false. It's not a great way to match. Oh, get occupied. This is what it is. Okay. I think that's what I want. Occupied is now an FN that returns an option. Space -1. space, space plus 1. And I'm actually going to do this unwrap or true. So now this returns that. So this is going to see if space space minus 1 and space and space plus 1. There we go. Cannot find. Let's just do this unoccupied. I like that. There we go. And actually that's going to be false here because if we're out of bounds, it's not occupied. I don't know if that's true, but I think it is. So this is creating an internal function that is going to return if it's occupied. If we can get, when we get the space there, that it is occupied, and in the case we're going to unwrap that in the case that it's not occupied, we're returning false, meaning that if we're on the edge, we're able to plant, that's considered to be unoccupied. We're just taking the negative of this so that this if statement returns, or this conditional makes sense. So if the previous space, our current space, and the next space are all occupied, then we can plant. Okay. So, I mean, this is the this is the core of what we need to do, and I think I've turned it into a simple version of this. So let's just say assert can plant if our flower bed looks like well 0 0 0 1. If we want to plant in space 0, we can't. Right? Let's see. Oh, it's attempted to subtract with an underflow. So this is 0. Do we want? Yeah, we do want to manage that. So I want this to be delta. So -1, 0, and 1. So if the previous, the delta previous and the current and the next are all unoccupied. So space I don't want saturating, checked add. And we're actually, this is going to be not a U size, but it's an I size. Checked add signed is going to be delta. So I think then we can do space map space flower bed, get all that stuff. And I think if we close this off here, unwrap, or I was going to say there's an option. Expected an option, found a bool. This just needs to be a then. Yeah. And this is delta. Good? No, this needs to be an I size. Good. Okay, so let's test our can plant. So we can't plant in 1. We can plant in 2, 3. Sorry. 0, 1, 2, 3, and 4. 0, 1, 2, 3, 4. Well, there we go. That's our proper test. So there's only one place we can plant. Let's do this. So 0 here, we can plant in 0, according to my rule. And in this case, we could plant in 4 because we're on the edge. Now, what if we go out of bounds? 5. We shouldn't be able to plant in an out of bounds one. So let's fix that. So we really want this to be space is less than or equal to flower bed dot length. Panicked. Oh, panicked because of that. Zero, 1, 2, 3, 4. Oh, it's got to be less than, not equal, because length is 1 greater than it. Good. So now we got a good set of tests. The boundary things out, spaces outside of the boundary are considered unoccupied. Good. I think that is all good. So now all we have to do is available spaces is going to be our flower bed. We really need our indices of that. So let's do it this way. Possible spaces are going to be from 0 to flowerbed.length. The available spaces are going to be possible spaces filter space, right? Yeah, where let's call this plantable spaces. PLANT. The plantable spaces are going to be the spaces where we can plant in our flower bed at that space. Wow, doesn't that just look really great? Like just from a readability point of view. So these are our plantable spaces, and the number of plantable PLANT plantable spaces is going to be plantable spaces dot count, and we can plant n flowers if n, or if the number of plantable spaces is greater than or equal to how many flowers we have. It's really going to be a use size. Good. That's pretty. And there's our test. A lot of stuff there, but so this is the thing where I'm not looking to get this done as fast as I possibly can. I am looking, what is this? I'm looking to make sure that I am absolutely sure that this works. And so like this, can we plant here? Like this is, like I know this is right. And so is then this sort of. I've used a trait to know whether or not something is occupied just because they used really the wrong type. Like this is one where if we want to implement this for bool, we just return self, or star self. Let's make this clean here. Good. Nice. Let me submit this first. Well, I actually do. I want to do another version of this. So, can plant in a slice. So flower bed is going to be a slice of that. And in this case, can we plant in this slice of 3 flower beds? And this is really flower bed all so this is where this needs to be an impl of an into iter of these sorts of things. Into iter all space is impl. Hold on, I'm parsing this. Takes 0 arguments, item equal that. There we go. So this is saying, okay, if we have a sequence of things, can we plant into this? And we can only plant into there if all of those are not occupied. And actually, I'm thinking, once we do plant into that spot, we have to jump ahead one. So, like, this is actually not going to work right. No, I'm going to delete all this because this isn't quite right. I'm starting over, sort of. So I want to change this into cam plant space. I called this slice, didn't I? Impl takes 1 argument. Oh, so I'm changing this. So 0, 0, 1 here. Man, 1 second. I need to let my dog out. Do you have to go outside? No, you just want to play. Yeah, mom left. I'm sorry. Okay. Can we plant this slice? Flower bed spice trait is not implemented for @integer. Oh, for sure. Flower bed space for we double. Oh, there we go. Good. So in this, basically what I want to say is, okay, if we have 3 things, there's here, like if any of these are occupied, we can't. If they're all empty, then we can, right? That's what this means. You know, we have this sequence of 3 things. And I believe I've set this up to where 2 is also good. And I guess technically 1 would be okay as well. Good. This is easier. And we can plant in this sort of slice if all spaces are unoccupied. It's not quite what the thing says, but we're going to give it so these are our possible spaces. Ooh, there we go. From 0 to the end, and possible slices now are going to be the possible spaces, and we need to give it, we're going to call these ranges. So we're going to go from space is a map, space saturating add signed -1 to space saturating add signed of 1. Nice. We're going to go to max of that and flower bed length. Whoa, hello. There we go. So this should now be all of our possible ranges. Possible slices is going to be possible ranges, map range, flowerbed.get range, which is going to be an option, but I believe that they're all going to be valid because we're, yeah, these are, unwrap is safe. Let's call this safety. Unwrap is safe because our ranges are all between 0 and flower bed len. So these are all of our possible slices that we can go into. So what we now need to do is start planting. Now, when we plant, I believe we then need to skip. Because if we do plant, we are not going to have that space is not going to be available for a seed. So while n let's call this let available seeds equal n. We need to find a place to plant. Available plots is going to be our possible slices filtered on if we can plant in this slice. Yeah. What is this not like? Iterator's not implemented for something. What's this? Filter, slice. Give me a second to work this out. Ranges, enter range, the possible slices then. We map our range. Why is that not getting me that? Iterator of item range. Possible ranges map range flowerbed.get. There we go. Plots is our possible slices. Why does this not give me that? Possible ranges is an iterator of range. We're mapping this and we're trying to get the bed, flower bed in that range. Oh. Yeah. And we unwrap because it's safe. And this says, yeah, so I just have to dereference that. Trait bound is not satisfied. Flower bed space is not implemented for at flower bed space. Well, that's interesting. I think I can just do that. We need silly lifetimes. What a silly thing. Okay, so here are now all of our available plots. So the problem is that I'm actually, I feel like I'm making this too too challenging. If new flowers can be planted without violating the no adjacent rule. So it's just that. Let's go back here. Available slices. Let's just go with this. So, because we need to consume the spaces that we could go into. So while I'm trying to think if this problem is actually written such that it could be more beneficial to skip a space, but I'm not sure that that's actually the case. Let's say that this is not. I believe this has to be mute. So if we can plant in this slice, then available seeds minus break. Actually, we're in a loop. If, so we're looking at the next possible slice, and if we can plant there, we do. Otherwise, and this is the outside one, we're out of spaces and we cannot plant. So if we get to here, then we return true. I think we're good. So 261. Two is false. Oh, 260. Now here I say we cannot. So I've actually made this like almost worse. So here's our ranges, possible slices, available seeds is 1. So we're going to loop here, we're going to get the next slice. Our next slice here is going to go from 0 to possible slices. Spaces from there to there. Why are we getting the whole slice? Yeah, we're getting the whole slice. There we go. So we're in from one back to one forward. Spaces, spaces. So possible slices. We're always going to get something there. Our possible slices dot next. It's going to get the first range. Let's actually break in here. Curious. So space is 0. Min. There we go. So our next slice here now, 1, right? We can't plant there. 1, 0, we can't plant there. 0, 0. Minus 1 to 1 equals. Yeah, we need that. Break. Unwrap on a none. Flower bed to get range. Minus 1. Good. Okay, so now we're passing. And we're probably let me just walk through this. This one took a lot longer than I wanted it to take. So we have this now can plant in a slice, and in this case, the way we're defining it is that we can plant in this slice if all the spaces are unoccupied. And we're actually only going to be getting slices of 3, and by definition, we can plant in that area. We're saying, well, we can really plant in. We can plant there if nothing is like these are all these sort of adjacent, including ourselves. So this can plant is greatly simplified. In this case, all of the possible spaces are from 0 to the length of the flower bed, and we got to deal with the minus 1s in this sometimes. The possible ranges now are going to be this. So we start from our space and we go minus and greater than where our current space is. And we grab the slice of flower bed spaces. Well, we create a range that is within our flower bed area. So we subtract 1, we add 1, we do an exclusive range, inclusive. And because we're doing the dot equals, we have to take len minus 1. we get all of the slices that are available here. And if we can plant in that slice, we actually need to grab another one. So eat the next slice because we cannot plant in this next one. So possible slices next, and we should still pass this, but it'll probably now allow all of the other ones to work right. So let's now run this here. We also need to pull in our traits, don't we? Good. So let's run this. And we pass. Okay, let's move on. There's an interesting implementation here. Wow, we did really well on this one. I might go back to look at this. But I want to move on. It's 10 o'clock. We've been doing this for almost 3 hours. Is that right? Something like that. Nobody's watching me. How sad. Oh, I didn't show you this one here. Here's how we scored. And actually, when I put it in here, I did this where I copied in all of my code as is, and then I adapted their bad vec implementation into the right one, and we did really well. So let's go to one more, and then we're going to call it a morning, and I'm going to get some lunch or something. Okay, given a string S, reverse only the vowels in the string and return it. The vowels are A, I, or U. They can appear in both lower and uppercase more than once. What does this mean? So we just need to have like two indices. We're going from back to front. And if it's yeah, this is easy. Okay, so here we go. Let's write our test first. Test, fn test, reverse vowels, 325, or 345, yeah. It's a nice, three, four, five. We're giving it ice cream, and we expect to get this. Yeah, let's do this one. And let's go ahead and put in the other one as well. Input is LeetCode. Nope. Put is LeetCode seed. There we go. So now let's implement this. Fn solve vowel something, and we're given an S, which is going to be a string slice, and we're going to return a string. So let's pub. Oops. Recompiling. Good, we're compiling. So let's do fn is vowel. It's going to be a char. What are our vowels? A, E, I, O, U. Two lowercase. I think that's the right way to do it. Expected car found. Returns an iterator that yields a lowercase mapping of this char to one or more chars. Are there more than one? You can have more than one Unicode mapping. Okay. Any of these. I think we have to move this. Let's do this. So there's this lower case. Isn't that what that returns? C is vowel, lowercase. Returns two lowercase. Right? I never knew about this one. Turns an iterator that yields the lowercase mapping of this char to one or more chars. Oh, shoot. Two lowercase. Core char to lowercase. Oh, let's just do this. Impl iterator where item equals C. And this is where C.any const vowels equal char equals A-E-I-O-U. Good. Any of those vowels enter any of those, B is C. Just going to move there. Good. Here, 5. Let's do it this way. A little cleaner. Item is a char. Cannot mutate it. Okay, so now that is going to be a vowel if is vowel lowercase to lowercase. Good. So this is, do we do this? Yeah, let's go ahead and do our tests. So assert A is vowel lowercase, or it is vowel A. Me, I-O-U, but not J. Let's just do the capital one too. There we go. Okay, now we'll do this one. So this was our like complete, like this is always going to be right. So in this case, we just need to go, okay, like what are our reverse vowels? The reverse string is going to be S. Into, sorry, chars reverse vowels reverse vowel indices are going to be the reverse stir enum filter C comma det is vowel C map bit I think that's right. Expect to take one argument, but it takes two. It takes two, baby. It takes two, baby. Is vowel. There we go. Set of all. So walking backward. We're only going to take half of this. No, I want to take the full thing. Reverse vowel indices. No, we just want the reverse vowels. We don't need to filter. Yeah. We can just map. Oh, we do need a filter. We want to filter if C is a vowel. Good. So these are all of the vowels in reverse order. So now we're just going to build this up in forward order. Forward stir is s.chars, and we just now want to say if our we can just do forward stir. Nope. Forward stir map C, and we're going to do two things. If is vowel C, then we want the other one. Reverse vowels next unwrap safety. The number of reverse vowels is the same as the forward. Otherwise, we return C. Collect. That's going to be mute. Good. So nice, clean version of that. Really happy with this. So what are we doing? We have our version. Is any character in this iterator of guaranteed lower case characters a vowel? Could actually do this, I think. I'm going to put that in there because I don't have like an into iter. I can't say that this item is absolutely going to be a vowel. No, I can. Let's do that. Impl into care for must be vowel. Self 0. Yeah. Impl must be, we're not going to do that. Okay, so two lowercase returns an iterator because apparently in Unicode you can have multiple characters that yield the same. Well, sorry. Char special considerations. Multiple chars of the iterator yields characters given by special casing. I don't even want to look into that. But apparently lowercase versions of a character can have more than one mapping. Anyway, so we want to say, okay, is any of these a lowercase value. And so these are our vowels. So we want to look at any of them. If any of those, and if any of the vowels are that value, then we're going to return true. And we have a test for this. So our is vowel all the way to the bottom here. We have a mostly exhaustive test. Don't have all of them. So this is going to work right for Unicode and everything. Returns true if this character is a lower. Yeah. Is a vowel for all Unicode implementations. It's work for everything. Awesome. So now to reverse it, we get a, this is our string in reverse. And we get all of the vowels in reverse order. So we're simply just getting an iterator of all of the vowels in reverse order. Because any vowel that we do encounter when we're going in forward order, if that is a vowel, we're going to take the reverse side of it. Really, really slick here. So now we have a forward version of our iterator, and we map the forward. So when we go forward, we say, okay, is this a vowel? If it is a vowel, then we're going to get the next vowel in reverse order. And we put a safety statement saying that this is always going to have a value, because when we go forward, we're going to get the same values as we do when we go in reverse. Otherwise, we return C because it's not a vowel, it's a consonant. And we just collect all those. So collect is going to know how to collect that into a string. Really, really slick here. So we test all of them. Well, we test all of the ones that we have here, and it works. And I'm guessing that this is going to be very efficient in the LeetCode implementation of this as well. So what are we calling? I'll pass that in. We're going to run it. Should run and submit. I can't imagine that there's a faster way to do this. Assertion failed. C is lowercase. What? Oh, a space. Okay, so that's interesting. Okay, we can just take that assert out. Oh, that was interesting. Beats 12.8%. I don't know that you could go faster than that. Like, this is probably, well, I'm not going to argue with this right now. Analyze complexity. Reached the limit. Ooh. Can you rerun it? Okay, I'm going to call this a day. We're on LeetCode 75, I think. So we've only done 5. Man, So, this is going slow, but I'm really happy with the solutions that I have here. So I'm gonna go get lunch, breakfast, whatever meal you want to call it, and we'll come back and look at this. Let me just look at these so I can think about it during lunch, so I'm not thinking while coding. Input string, reverse the order of the words. Words is defined as a sequence, so this is an easy thing to do with iterators in Rust. Okay, that's an easy one. I don't know why that's medium. Probably if you're doing sort of yeah. Product of an array except self. Give an integer array of nums, return an array answer such that answer sub I is equal to the product of all the elements of nums except for that. Okay, this is an easy for they want you to run it in order n times. So you're gonna find the sum of all of that, and you're gonna subtract out your number. Yeah. Increasing triplet subsequence. Given an array, integer array nums, return true if there exists a triple of indices I, j, k, such that all of those are less than each, or they're in numerical order, and those exist. Okay, I'll brute force that. String compression. Give an array of characters, compress it using the following algorithms. Begin with an empty string for a group of consecutive repeating characters in char. If the group's length is 1, append the character s. Otherwise, append the characters followed by the group length. Group lengths that are 10 or longer will be split into multiple characters. Right. Okay, that's a fun one. And I think move zeros is going to be, yeah. Okay, so we're going to do the next ones, and keep going. It was sort of fun, I guess. I don't know if it's interesting, but I'm going to sort of keep streaming here, and we'll see. We'll see you on the other side. Let's end the stream.